All right, let's dive right in. Today, we're going to talk about something we've all run into when using AI, the refusal. We're going to look under the hood to see what's really happening when a system says no, and it all comes down to something called policy and safety layers.
You know the feeling, right? You type in a prompt, you think it's perfectly fine, and the system just shuts you down, or it gives you this super watered-down answer. So why? Why does that happen? It's a really fundamental question if you want to understand how these tools actually work.
To get to the real answer, we first have to unpack our own gut reactions. So let's start with what I like to call the misleading no, because our first instinct is usually way off from what's actually going on.
When an AI tells us no, it's pretty natural to jump to a few conclusions. You might think, oh, this thing is way too cautious. Or maybe it feels biased. Or, and this one is super common, you've seen a similar prompt work on a different tool, so you just figure the system is being totally inconsistent. These are all completely normal reactions.
But here is the absolute key. While those feelings are totally valid, they're misleading. They're based on this idea that the AI is like a single person making a judgment call. And that's just not how it works. So to really get what's happening, we need to move past those simple analogies. We need a much more accurate way of thinking about this, a more formal model for how these systems are actually built.
And that brings us to this really important difference between a mental model and a formal model. See, a mental model is great for our gut feeling. You know, thinking of the AI as a helpful assistant. It's a good starting point. But to really understand its behavior, especially around safety, we need a formal model. That's like the actual blueprint, the kind of thing you'd need for an audit to ensure it's operating safely. So yeah, if we really want to get to the bottom of that no, we have to switch hats. We need to stop thinking of it as a personality and start looking at it through the lens of a formal structural system. And that's exactly what we're about to do. So let's pull back the curtain and actually look at the anatomy of one of these systems. Because this is where you see that the response you get isn't coming from one place. It's the end result of several different parts working in concert. And here it is, the foundational concept you have to grasp. An AI is not a single brain. It's a system, a whole collection of different components, and each one has a specific job to do. The answer you see is just the final product coming off this assembly line.
So what are the big parts? Well, you have the core model. That's the part that actually generates the words. But working right alongside it, you have things like routing systems, and most importantly for us, these separate policy and safety layers. As you can see, the model itself is just one piece of the whole puzzle.
These policy and safety layers are everything. Think of them as the bouncers at a club. Their entire job is to enforce a specific set of rules, constraints, on what the system is even allowed to create and show you.
And this part is so crucial. These layers work next to the model, not inside it. They are not part of its thinking process at all. They're totally separate components that act like guardrails, checking what goes in and what comes out against the list of rules.
Okay, so that's the theory. But what does this actually look like in practice? Because it's definitely not a one-size-fits-all situation. Context is absolutely everything.
Right. A systems policy isn't universal. It's not the same everywhere. It is specifically designed to change based on the context you're in. Things like how much risk is acceptable or what regulations have to be followed, those play a massive role.
This table just lays it out perfectly. Imagine you use the exact same request in 3 different places. In a public demo, where the risk tolerance is super low, that request gets refused. Simple as that. Now, take it to a regulated enterprise tool. The policy there might let the request go through, but the answer will be constrained to meet compliance rules. And finally, give it to an internal developer tool where risk tolerance is high, that same request is allowed.
And that is the reason for that feeling of inconsistency we talked about earlier. It's not that one model is smarter or more relaxed than another. It's that they are operating inside systems with totally different policy layers, built for totally different purposes. Okay, so let's wrap all of this up. Once you understand this system-level view, you can start to see that no in a whole new light. It's not a failure. It's actually predictable, by design.
A refusal from an AI is not personal. It's not some random arbitrary decision. It is not the model deciding it doesn't like what you asked.
What it is evidence. It's proof that the system's components, especially those policy and safety layers, are working exactly the way they were designed to. The system isn't breaking. It's doing its job.
And this is really the single most important thing to take away from all this. When an AI says no, you are not witnessing an intelligence failure. You are witnessing boundary enforcement. That's it. It's a system enforcing its rules. And understanding that changes everything about how we see and use these incredible tools.